The wind hits first. Hardest, not the cold, the wind it slams into the ridge like something with intention. Like it wants you gone, visibility drops to nothing in seconds, white on white on white. And somewhere in that whiteness, a man is moving, hunched under 50 pounds of gear, crampons clinking against his pack, searching for a shape he can barely remember the direction of. This is the moment most people would call the end of the story, the moment everything seems lost, and yet it has survived decades of them. A curved metal shell, no windows to speak of, a single door, a chimney pipe poking through snow. Out here, at this altitude, in this weather, it usually is, but it isn't, because somewhere ahead, buried halfway under snowdrift, sits a structure that has no business surviving conditions like this, and yet it has survived decades of them. A curved metal shell, no windows to speak of, a single door, a chimney pipe poking through snow that would crush almost anything else built by human hands. This is the story of that shelter, why it exists, why it works, and why. Of every survival structure built for the world's most brutal mountain environments, this design might be the smartest one nobody talks about. Stay with me, because by the end of this video, you will understand something that could genuinely save your life if you ever find yourself caught above the tree line in a storm that doesn't care whether you make a home. Let's start with the obvious question. What is this thing? It's called a Quonset hut. Some call it a Nissen hut, depending on which side of the Atlantic the design came from. Either way, the shape is unmistakable. A half-cylinder of corrugated steel, rounded like a barrel cut in half lengthwise, sitting low and squat against the terrain. No flat roof, no sharp angles, no vertical walls fighting the wind. Just one continuous curve from ground to ground. That shape is not decoration. That shape is the entire reason this structure survives where wooden cabins and canvas tents fail. Here's the part most people miss. A flat roof has to fight snow load directly. Every inch of snowfall sits on top of it, pressing straight down, and eventually something gives. A beam cracks, a support buckles. The whole roof comes down on whoever is inside. It happens more often than people think, even with well-built cabins in heavy snow regions. A curved roof doesn't fight the snow. It sheds it. Snow that lands on a curved slide settles and redistributes its weight along the structure instead of concentrating in one place. The hut isn't resisting the mountain. It's cooperating with it. That's the first lesson buried inside this design, and it's one engineers have known for over a century. In extreme environments, the structure that survives isn't always the strongest one. It's the one shaped to let the environment slide past it instead of slam into it. Now think about wind. At altitude, wind isn't a breeze. It's a moving wall. A flat-walled structure presents a vertical surface of that wall to push against, and over time, that pressure finds every weakness. A loose panel, a warp seam, a door that doesn't sit quite right. The curved shape of a Quonset hut does something different. Wind moves across a curve the way water moves around a stone. There's less surface resistance, less direct force, less chance of catastrophic failure during the kind of sustained windstorms that can last for days at high elevation. This is where the story gets interesting, because the design itself was never built with mountaineers in mind. It started as a wartime necessity, far from any mountain, designed by people solving an entirely different problem under entirely different pressure, and yet it ended up answering a survival question nobody had even asked it to solve. The Quonset hut was a wartime invention, built fast, built cheap, built to be dropped into hostile environments with minimal tools and minimal time. Steel ribs, corrugated panels, bolted together in a matter of hours by a handful of people. It was never meant to be beautiful. It was meant to work immediately in places where nothing else would. And that's exactly why it ended up on remote mountain ridges decades later. Because the same qualities that made it useful in wartime, speed of construction, resistance to weather, minimal need for ongoing maintenance, are precisely what a high-altitude shelter needs. There are no construction crews coming up here for repairs, no supply chains or replacement parts. Whatever gets built has to survive on its own, year after year, storm after storm, with almost nobody checking on it. Think about what that really means for a moment. Somewhere, decades ago, a small group of people hauled steel ribs and corrugated panels up terrain, that would exhaust most modern hikers using nothing but the gear they could carry on their backs. They bolted it together piece by piece in conditions that probably looked a lot like the storm you just watched in that footage. Then they left, and the structure kept standing, through summers that thawed and refroze the ground beneath it, through winters that buried it under snow loads heavy enough to crush lesser buildings, through years where nobody came back to check whether it had survived. That's the quiet miracle hiding inside this design. It doesn't need anyone's attention to keep doing its job. Most shelters fail not because the original engineering was wrong, but because nobody maintained them. Wood rots, canvas tears, hinges rust shut. The Quonset hut sidesteps almost all of that by relying on a single, simple structural principle instead of dozens of small components that each require upkeep. That's survival lesson number 2. Simplicity outlasts complexity. The more moving parts a shelter has, the more things can break. A door for walls and a curved roof. There's barely anything here to fail. No complicated drainage system, no elaborate framing, no joints under constant stress. Just steel, bent into a shape that worked for gravity instead of against it. Now, here's where I have to be honest with you, because the worst thing I could do right now is feed you a number that isn't real just to make a headline sound impressive. I'm not going to pretend I have an exact dollar figure for what it costs to build one of these huts and ship the materials to a location like this. The truth is, the real cost isn't really about the price tag. It's about what you're getting for it. And what you're getting, compared to almost every other shelter option at this altitude, is enormous value for very little material, compared to alternatives. A traditional timber mountain lodge needs continuous heating, structural maintenance, and a foundation that has to be engineered against frost heave. A canvas expedition tent might cost a fraction to buy, but it offers almost no protection against sustained extreme wind and provides no long-term shelter at all. It's built for days, not years. Helicopter-supplied high-altitude camps cost more per night than most people make in a week, and that's before accounting for weather delays that can strand supply runs for days at a time. There's also the question of what happens when something goes wrong with each of these alternatives. A timber lodge with a damaged support beam needs skilled carpenters and replacement lumber hauled in by vehicle or aircraft. A torn tent in a windstorm is finished. There's no patching canvas in the middle of a blizzard with frostbitten hands. A helicopter camp depends entirely on weather windows that can close without warning, leaving a crew stranded exactly when conditions turn dangerous. Every one of these systems has a failure point that depends on outside help arriving in time. The Quonset hut has almost none of that dependency. If a panel loosens, it can usually be resecured with basic tools already inside the structure. If the door freezes shut, a few minutes of effort usually solves it. There's no system waiting on a supply chain, no specialist required, no narrow weather windows standing between the people inside and the help they need. The entire philosophy of the design is self-sufficiency, and at extreme altitude, self-sufficiency is worth more than almost any other quality a structure can have. The Quonset hut sits in a category almost nobody else occupies. Cheap materials, minimal construction skill required, no ongoing heating system needed to keep the structure itself intact, because the steel shell handles wind and snow load on its own, regardless of whether anyone's inside lighting a stove. It's not luxurious. It's not comfortable in the way a heated lodge is comfortable. But comfort isn't the question that matters at this altitude. Survival is, and on that metric, this design has very few rivals. Now let's go inside, because this is the part that actually matters if you're ever in a situation like this yourself. Step through that single door, and the world changes immediately. The wind disappears. Not muffled, gone. That's the second thing people don't expect. The curved steel doesn't just block wind. It kills the sound of it almost entirely, because there's no flat surface for the wind to vibrate against. Inside, it's quiet in a way that feels almost unnatural after hours of being battered by a storm. The space itself is small, intentionally small. Every cabin builder who has ever worked in extreme cold knows the same rule. Smaller spaces are easier to heat. A large open room loses heat fast, and out here, heat is the single resource you cannot afford to lose. So the interior is tight, bunks along the curved walls, a small stove near the center, minimal furniture, nothing wasted. That stove is doing more work than people realize. In a space this size, even a modest fire can raise the internal temperature by dozens of degrees within an hour. The curved steel walls, instead of radiating heat away the way flat wooden walls might, tend to hold warmth inside the enclosed half-cylinder shape, circulating it rather than letting it escape upward into a peaked roof the way a traditional cabin would. Even the bunks are positioned with this in mind, raised slightly off the floor where cold air settles, keeping anyone resting closer to the warmest layer of air in the room rather than the coldest. This is where I want to pause and ask you something, because I think it matters more than people realize. If you were caught outside right now in a storm like the one in this footage, with the wind screaming and your hands going numb, would you know what to look for? Not a hut specifically, a shape, a principle. Would you recognize that a low, curved structure is statistically safer than a tall, flat-walled one? Would you know that smaller is warmer, that fewer moving parts means fewer failure points, that the structure cooperating with wind and snow always outperforms the structure fighting it? Because that knowledge, not the hut itself, but the principle behind it, is the kind of thing that has saved lives in conditions exactly like this one. Now, about the claim of zero complaints. I want to be straight with you here, too. I'm not going to manufacture a guest review or pretend there's some 5-star rating system for emergency mountain shelters, because there isn't, and pretending otherwise would be dishonest. What I can tell you is this: structures like this one have a track record. They've stood in some of the harshest weather systems on the planet for years, sometimes decades, without major structural failure. That's not a marketing claim. That's a maintenance record. The reason there are no complaints isn't because everyone who's used one had a 5-star experience with hot showers and room service. It's because nobody who has reached one of these huts in a genuine emergency has ever complained about being alive, when the alternative is exposure, frostbite, or worse, a small, cold, quiet metal room with 4 walls, and a working stove stops being an inconvenience and starts being the single most important structure in the world. That's the real reason this design earns trust. Not comfort, reliability. When everything else around you is unpredictable, the weather, the terrain, your own body's response to altitude and exhaustion, having one fixed, dependable point that you know will still be standing when you reach it changes everything about how you plan a route, how much risk you're willing to take, how far you're willing to push before turning back. Let's talk about that for a second, because this is something every serious mountaineer understands, and most casual hikers never think about until it's too late. Shelter placement changes decision-making. If a climber knows there's a reliable structure at a certain point on a ridge, that knowledge becomes part of every calculation they make. How much daylight they've left, how much risk they're willing to accept in deteriorating weather, whether to push forward or turn back. Remove that shelter from the equation, and suddenly every decision becomes more conservative, more cautious, more limited. A single dependable structure, placed correctly, can extend the safe operating range of an entire route. This is something search and rescue teams understand intimately, even if they rarely explain it in these terms to the public. Most fatal incidents in extreme cold environments don't happen because someone made one catastrophic mistake. They happen because a series of small, reasonable decisions compound under pressure. Pushing on an extra hour because turning back felt premature, taking a slightly riskier route because the alternative looked too long, underestimating how fast conditions could change once the light started fading. A known shelter on the route doesn't just provide physical protection. It removes one layer of uncertainty from every decision leading up to it, which means fewer of those small, compounded mistakes ever get made in the first place. That's not a small thing at all. That's the difference between an expedition that succeeds and one that ends in a rescue operation, or doesn't end at all. Now, picture the moment in that photograph again. A man, beard frosted white, pack loaded with crampons and rope, finally within sight of that curved steel roof after hours of moving through conditions that strip away your sense of direction, your sense of time, your sense of how close you actually are to real danger. That moment, the second the hut comes into view, is the entire reason structures like this exist. Not for comfort, not for convenience. For that exact second, when exhaustion and exposure are closing in, and somewhere ahead there's a fixed point that you know, with certainty, will still be standing. So where can you actually find structures like this? They exist scattered across high-altitude expedition routes worldwide. Old mining regions, remote scientific outposts, mountaineering base camps that have relied on prefabricated steel shelters since long before modern lightweight materials existed. Many of them were never built for tourism. They were built because someone, decades ago, needed a structure that could survive without maintenance in a place almost nobody would ever visit twice. Some of them are still maintained by mountaineering clubs or research stations. Others are simply left standing, slowly being buried and uncovered by shifting snow year after year, waiting for the next person who needs them more than they'll ever admit. If you ever come across one of these during your own travels, take a moment to actually look at it properly. Notice the seams, the rivets, the way the curve handles a load pressing down on it. Notice how small the doors compare to what you'd expect from a building meant to shelter people. That's intentional too, because every square inch of opening is heat escaping and wind finding a way in. Even the chimney pipe, small as it looks against the surrounding landscape, tells you something about how the builders thought. Minimal openings, maximum function. Nothing included that wasn't strictly necessary for survival. If you're planning any kind of serious cold weather expedition, here's the practical takeaway. Because I promise you this video would be useful, not just interesting. First, know the shape that survives. Curved, low, minimal surface area against wind. If you're ever building an emergency shelter for materials on hand, remember that principle. Work with the wind and snow, not against them. Even a simple snow cave or improvised wind break performs better when it mimics this curve instead of trying to stand rigid against a storm. Second, pack for heat retention, not heat generation. A small space with minimal airflow loss will always outperform a larger space with a stronger heat source. Insulation and size matter more than raw fuel. This is why experienced winter travelers often choose to dig in rather than pitch a large tent. A tight, low space holds body heat far longer than an open one, even without any external heat source at all. Third, never underestimate the value of a known fixed point on your route. Whether it's a hut like this one, or simply a marked emergency shelter, knowing exactly where reliable protection exists changes every decision you make on the way there. Before any serious cold weather trip, study the map for these points the same way you study it for water sources or trail junctions. Treat them as essential waypoints, not optional curiosities. And fourth, this one matters most, respect structures like this. Don't damage them. Don't strip them for parts. Don't treat them as disposable just because they look weathered and forgotten. Someone, someday, may need that exact shelter exactly as badly as the man in this photograph needed it. These structures have outlived their builders. They deserve to outlive whoever passes through next. That's the real story behind this image. Not a cheap trick of a title promising more than it delivers, but a genuine look at why one of the simplest, oldest shelter designs in the world remains one of the most effective survival structures ever placed on a mountainside. Cheap, yes, but cheap in price, never cheap in value. Built for survival, and proven by decades of brutal weather that never managed to bring it down. And as close to zero complaints as any structure can claim, for the simplest reason imaginable. The people who needed it most were always glad it was there. Every detail in this story points back to the same idea. Survival in extreme cold isn't about brute strength or expensive equipment. It's about understanding the environment well enough to design something that cooperates with it instead of fighting it. That principle applies whether you're looking at a century-old steel hut on a frozen ridge or planning your own next winter trip with nothing more than a backpack and a map. The mountain never changes its rules. The only thing that changes is whether you understand them before you need to. If you found this helpful, let me know in the comments. I genuinely want to hear your thoughts. And if you want more videos like this, breaking down real survival principles behind extreme cold weather environments, subscribe for more videos about how to survive cold winters.